And we continue with the next session, which is exactly about this subject, small commuter aircraft. So hello, everybody's coming back on again. So now we are preparing for the next session. Would be great that which is Qingying from Rolls-Royce. So Qingying, if you show your screen and everybody else switches his screen off, and then we will have the next speaker right after Rolls-Royce, which will be Fabio Russo from Tecnam. So Qingying, yes, you have presented already several times at our events at eFlight Expo, at eFlight Forum. Thank you for this, and thank you for being with us again. And yeah, let's hear what Rolls-Royce thinks about the commuter segment. Stage is yours.
Okay, thank you really for the invitation. It was always a joy to join the eFlight Forum China. Okay, I think you're sharing my presentation, so I just start with that. My name is Qingying Zhang. I'm working at Rolls-Royce, and currently I'm responsible for the market segment commuter aircraft. And today's presentation is about electric commuter, and I will also use content we generated within the project ELICA, which is acronym for Electric Innovative Commuter Aircraft. And so also Professor Fabrizio Nicolosi from University of Naples contributed to that, and also Maximilian Spangenberg from the Airspace GmbH. So what do we see the market segment? We do believe that there are three market segments: that's small propeller, urban air mobility, and commuter aircraft will enable early market entry for electric propulsion systems. So next slide, please. Yes, we have already gathered extensive experience in design electric propulsion system from commuter aircraft back to the year 2017, when we started the electrification project with the Dornier 228 project. And in that project, we designed a whole powertrain starting from our turbo generator, 500 kilowatt with battery system, and then for the propulsion, we also designed our RP600D e-motor with 480 kilowatt maximum continuous power. So based on, as you see, the whole powertrain is complete, and also in last year we manufactured the prototypes based on design and lab tested it. So actually in this segment we established a leading position. However, due to the transfer to the Rolls-Royce from Siemens e-Aircraft, we discontinued this project in favor of other upcoming projects. However, all the know-how remained in the team, and we can utilize all the competences we generate. Next slide, please. So with regard to the future, we started end of 2019 our project funded by the European Union in the Clean Sky 2 program. The project is called ELICA, Electric Innovative Commuter Aircraft, written on the left corner up. And the goal is to provide a concept for a 19 pax commuter aircraft with near zero emissions, contributing to travel time and emission reduction, setting as goals in flight past 2050. However, we believe once the platform is established, we can easily adapt the platform design and optimization platform downward to the 4 and 11 seaters, and upgrade it also, or upscale it to 50 and 70 seater. So it's quite a strategic project to design such our optimization platform. Next slide, please. And within this project, we have built a consortium with very complementary skills. So Rolls-Royce Electrical has a coordinator role. I'm coordinating this project, and then significant contribution comes from University of Naples, leading by Professor Nicolosi. And then one of the spin-off from that university, the Smart Hub Engineering, is providing integrated CAD optimization tools, and also our partner from Belgium, the Siemens Industrial Software, NV, is providing innovative digital system architecture design tools, and a small startup from Aachen, which is building the silent edge taxi concept, is also part of the consortium. Next slide, please. So basically, we started the project from the economic perspective. We performed market analysis, for example, not only for Germany, also for Europe. We see there's around 2,000 airfields, airports, and around 80% of the EU population living within 30-kilometer radius to our existing airfield. So they would have access to local airfields. And the next step is cost analysis. We did some estimation for the range and also for daily operating hours. And then through the assumption about aircraft maintenance cost and also staff costs and so on, we could gain details into the cost proportion of such a hybrid electric aircraft, and we came to the conclusion that operating such kind of aircraft will provide economic benefits to our operator, and roughly speaking, we expect an annual profit of 10% for such kind of aircraft. It will increase also its competitiveness of the operator if they use such kind of aircraft. And based on the economic analysis, we then do requirement for such kind of aircraft, including the weight, the maximum, the takeoff length, and cruise speed, and also range, so that we can perform further studies based on these pillars. Next slide, please. And next step is after the economic analysis, we perform, of course, also an overview of the enabling technologies. So we performed a literature survey and performed technology survey for different fields, for example, propulsion, aerodynamics, and structures. To sum it up, we've from the energy storage and propulsion side, we believe fuel cell batteries and hybrid electric architectures will provide benefits, and also we have performed the first analysis which electric architecture will be rather promising. And on the next step, we studied the aerodynamic integration effects. For example, we believe wingtip propellers and distributed electric propulsion will provide benefits. Less, for example, would be the boundary layer ingestion or laminar flow technology. And from the structure side, we are still perform ongoing studies. However, we think the main drivers were from the propulsion and aerodynamics side. Next slide, please. So after the technology survey, I just explained it, why is our approach innovative? Because the University of Naples already has a aircraft multidisciplinary optimization framework for commuter or turboprop aircraft in general. What we are doing is we introducing electric powertrain modeling and design aspects into this validated tool chain. And we also, one of the main aspects is to perform such kind of study. You need to be able to capture the aero propulsive integration aspects, which the tool is capable of, because it already has been proved in also via internal tests. And if you look at the picture left, what's the innovative aspect is we perform in the loop fault tree analyze, so we can already perform fault analysis in a very early stage of the system architecture design and layout. And if you go further to the picture in the middle of below, you see then we will perform our holistic optimization approach for system architecture and component design. You see the dashed blue line is the Pareto front. We can generate for the parameter of weighting, the parameters of weight and efficiency. And then lastly, in the last few months, we also created an in-the-loop cost model so that we also keep the cost of the powertrain always inside to filter some potentially very costly concept out of the study. So this is a complete design chain, and we are still performing analysis based on this, and the study is still ongoing. So I think next time I can already present the first results. Next slide. Okay, yes. So basically that was already the a short overview about what we are doing in the commuter range. And if you have any questions, please go forward. Thank you for your attention.
Yes, now I'm easier to unmute. Hello again, and thank you very much, Qingying, for this presentation. It is very interesting, and I think it's very important because when first Siemens and now Rolls-Royce steps into this kind of project, then it's very important for the industry and all. And you can see that in several segments, if one big player is in, also other big players are following. So the next project we'll see on the screen already is what Fabio Russo is presenting us, and we'll see the Rolls-Royce logo is on this project as well. And it is a project which was just released earlier this year. So it's pretty new, and I'm really curious to hear more about it. Fabio, it's yours.
Thank you, Willy. Yes, the project is really young. I would say we have press release for the first time on October. So it is a really, really young project, but it is really promising also because the interest that has grown around this project is really huge. It is not really wide presentation because the most of this project is still confidential, but it is really good to show how this project has started. First of all, we can disclose this picture with you all. That is the second picture. You can see about the P-Volt, and on the top you can see few of the hundreds of press release of echo that we collected, the Tecnam and the Rolls-Royce collected with this launch of new aircraft. It is important to underline that the P-Volt experience will start from the Tecnam P2012. The aircraft that you can see in the bottom right side of your screen has been certified on 2018. So it is really a new aircraft and it is the first twin-engine 9-passenger piston aircraft certified after more than 40 years in the entire worldwide arena. So this means that the aircraft has been certified with all the latest requirements, such as crash-worthy seats, fire protection devices, lightning protection, and entire aircraft sections subject to real lightning test, if protection, and so on. It is curious to note that today you can still buy a factory new aircraft, but if the aircraft has been certified 30 or 40 years ago, you are buying a new aircraft, but without accommodating all the new certification requirements. It's like if you buy a car today, a new car today from a car dealer without the airbag or without all the safety feature that you expect now on all new cars. So for this reason, P2012 is considered by Tecnam the natural step between the electric demonstrator and the really market-ready short-range aircraft. Also, it is important to note that starting from the experience gained with the P2012 will not drive energies of designing and retrofitting that are towards items and the certification aspect that has been already dealt. So it will be really not easier, but it will be more natural from Tecnam that owns the full design and the full modernity of the design of P2012, working on the P-Volt project rather than going on, for example, retrofit or entirely new aircraft. Also, as I was anticipating before, the P-Volt will feature, since its introduction, all safety features that have been already incorporated into the P2012 aircraft, and the P-Volt architecture, as you can see in the image in the screen, will be easily accommodated into energy storage, dedicated energy storage, as the energy storage will progress in the coming years, both on battery energy and as well as on hydrogen capability to store energy. Finally, the P2012 now is perfectly matching the small short-range airlines needs, and the P-Volt will even more perfectly match their needs. It is interesting to note that this is from planestats.com source. It is interesting to note that in the last years, those airports that has the smallest share of seats are those who has grown more. So those small airports are expected to grow even more, also to serve local communities. So P-Volt will aim to foster, I don't know who is writing on the screen, but by the way, it is still readable. P-Volt will foster communities' growth, especially if we look at the, as Qingying was anticipating before, at European, but also US and other countries' share of airport on their runway length criteria. As you can see, there is about 67% of airport with the runway from 1,000 meters and less. So this means that those 67% airports are not currently used on regional transport basis. And P-Volt project will aim to have all these airports and the related communities growth. growth means also the growth of manufacturers of batteries, of fuel cell, or local stations for recharging or swapping, depending on the technology that will be used. But this will mean that local community will not grow just on their connection level, but also on their industrial and economical aspects. As I was anticipating, and this is the last slide, P-Volt technologies and decision around P-Volt are mostly confidential, but market needs are not. And thinking of an aircraft that is full electric or hydrogen powered with a turnaround time, a ground turnaround time of more than 10 to 20 minutes will not have to be considered, in my opinion. So the aircraft, the P-Volt will guarantee extremely short turnaround time. Also, it will be highly integrated with the ground infrastructure that will be needed to keep the aircraft ready for the next flight, and will be oriented for highly standard definition. So this means that technologies developed for P-Volt will be on the potentially scalable up to CS-25 aircraft. You will see more in the coming months as most part of the P-Volt technologies will be partially disclosed. And also will match the short-range airline, and the smart mobility model will be matched, as I was showing before, and also with the mobility model that will be based on application, on the smartphone application. So this will be the right aircraft to enter this new mobility model. Thank you. Willie?
Sorry, just have to need one more click. Thank you, Fabio. And I have some more questions to this, and unluckily you say it's still confidential, a lot of stuff. So we'll see how much news we can get from you afterwards. Our next presenter also has a project where we heard some years ago, not years, 1-2 years ago, and I heard some rumors that there are some changes in the project. So welcome with me together, Professor Jeschke, CEO of eSAT project, and I hope I see the presentation.
Okay, perfect.
Now, perfect. Sorry for this. And now we put back on the presentation. And
everything is perfect. If you could play my video, that would be best, because then I keep exactly the time.
Dear ladies and gentlemen, thank you very much for being given the chance to present today. My name is Peter Jeschke. I'm co-founder and CEO of the electro-hybrid silent air taxi powertrain company, within which we have developed in Germany, in Aachen, what we call a noiseless and emission-free powertrain. And we think that such a powertrain may well propel any zero-emission aircraft with up to 19 passengers. The ground on which we have based our developments is always, of course, the same as in all new air mobility activities. We have all seen every day that we have traffic jams on our roads. We have crowded and sometimes cancelled train connections. Our scheduled flights do only depart on scheduled times and are cancelled also possibly sometimes and crowded. We have a large and heavy noise carpet on ground whenever our airfields are close to the cities or to neighborhoods. And of course we do have an emission problem, and we think that we can tackle this in the future by having sustainable powertrains and aircrafts, and we produce, let it be something like this here, multi-mobility hubs up to which we travel by sustainable trains, cars, or buses being driven by electricity. Only we change into a vertical takeoff and landing aircraft to fly possibly into the cities, or we step into, and that's what we tackle indeed, into some kind of a classical fixed wing horizontally flying aircraft, all of which could be propelled by our powertrain. However, such aircrafts as they are flying today are mostly propelled by propellers with only 2 or 3, only a few blades. Thereby they have to run at high speed to produce the required thrust, and they also have to run at variable speed and or with variable pitch. All of these features inevitably lead to loud propellers. At the same time, smaller aircrafts are most efficiently being driven by piston engines, not by gas turbines and not by battery energized electrical motors only. Both extreme alternatives are not possible. However, those piston engines, they of course produce emissions. And our target now is to have developed a ultra-silent ducted propeller, which we have already tested. It produces ultra low noise because of, first of all, we have a duct around it. We have a multitude of blades that may run slowly and at constant speed because we have some electrical boost to control the thrust at the very end. So we have a propeller that at about 300 meters distance we cannot distinguish from background noise, and this is why we say this is noiseless. And we combine this propulsor, this propeller, with a modular powertrain platform which we can include in the inner part of the aeroplane. And here in gray, in shaded gray, we see our aircraft. It has a fuselage which is wide enough to carry the energy. In this case, it is cryogenic hydrogen, and also the energy conversion system, fuel cells, which by themselves obviously are CO2 free, almost NOx free, and by which we can control the water droplets, avoiding contrails if we fly at higher distance, at higher altitude. And if we take that mechanical power, convert it in a type of parallel hybrid system into our ducted propeller, which I have described before, I think we have a perfect combination, best suited for those medium-sized aircrafts. However, fuel cells may not be fully developed, ready to be certified, and the rulemaking is not ready prior to 2027, if at all. So we have developed a bridging technology which is ready to use already now, more or less. And in our case, we target a type certificate in 2025, whereby we use a certified piston engine, have it electrically boosted, and drive exactly the same propeller. By changing that piston engine to be ready to use sustainable aviation fuels, in this case this would be ethanol, this is sustainable to quite some extent. By doing so, we think we can well propel any aircraft ranging from ultralight aircrafts to commuter aircrafts, which are now being propelled by piston engine or small gas turbines. We use the explained bridging technology and end up with a fuel cell propulsion system. We are not tackling Airbus A320 type aircraft. They are nicely propelled by classical jet engines or turbofans, which might be operated with sustainable aerofuels easily, and fairly easily can be converted to hydrogen combustion burners. By doing so, we have developed a sustainable powertrain for our aircraft, which is a 1800 kilogram max takeoff fixed wing aircraft carrying 4 passengers and 1 pilot. We provide a on-demand point-to-point air taxi that brings us from one small city to the other small city, which is the direct flight. We can have only about half the travel time compared to a classical transportation route that would be a train transportation to the next large airport, take a CS-25 aeroplane and go back by car or train to our final destination. Such a direct connection is short, energy saving, green with our sustainable powertrain, and it is quiet and thereby will be accepted by the neighbors, which are always nearby to the many small airfields that we find in many countries like in Germany. This leaves me to saying that it was a pleasure for me to present here today, and here I have listed my email and my telephone number. I would be very happy to find any contact from you. Maybe I can answer a question or do anything else to you. Thank you very much for your attention.
Even after today's presentation. Thank you very much for listening to me.
Thank you for presenting this interesting study and development what you're working on, and I'm really also interested in asking you several questions afterwards, because I have these questions already quite a while and never had time to get directly in contact. And the interesting thing is also I've seen you're really interactive, because I saw you moving through the breakout rooms. So the breakout rooms work, and we hope that more people can use it afterwards. So we will have, after this session, a normal Q&A again, because not everybody could join the breakout rooms, but then probably at the end of the day we'll have another breakout room session, because before we had quite some people who couldn't join. So our next speaker, so thank you very much for this presentation. I'll talk to you later in the Q&A. And now our next speaker is Jean Botti, the former CTO of Airbus, who when at his time as Airbus launched the project of the E-Fan. Yes, I'll play for him the video.
Good morning, everybody. Sorry I cannot be with you today, because I am in the other side of the ocean there. I am in the United States right now, but I wanted to say that I'm very pleased to be part of this e-forum, and I wanted to introduce you to the Casio experience, which is what we call it, the power to fly safely. And the power to fly safely because our Casio airplane is really with a dual mode of operations, being thermal, electric, or the combination thermal electric gives you additional safety in the world of what I call general aviation. So if we go into the first slide, so our family of Casio products resumes in 3 models. 330 Casio is 4 seats, the Casio 480 is 6 seats, and the Casio 600 is 10 seats. As you can see by the design, the airplane is very modular and versatile, and it's been basically made for configuring multiple configurations for serving customers, and with various mission profiles. We will come back to it. Our vision for electric aviation resides in 3 keywords: hybrid, which is a combination of electric motors and internal combustion engine, provide multiple sources of energy, from full electric, don't forget you can use this plane on full electric, to full hybrid when you have long distances to make. This is very dependent of the distance. And in the middle you obviously have mild hybrid, where you can use both energies, you know, to extend the range. This is very dependent of the usage scenario. Okay, if you have short distances, use pure electric. Mid distances is mild hybrid, and long distance is full hybrid. The second word is modular. Okay, Voltaero family will be available in 4, 6, and 10 seats versions, utilized for commercial flights, point to point, for regional travel, air taxi, charters, for example, utility categories, you know, for missions like cargo, postal delivery, medical evacuation. Those are very important, you know, I would say, tasks that our modular airplane can do. And finally, with private owners, you know, like me, I am a pilot. I'm sure there's plenty of pilots that are listening to this presentation. So private owners, obviously, is also one of our targets. The third word I would like to mention is experience. And the Voltaero has combined years and years of experience now in electric aircraft. This is the third airplane we make, you know, with our team. We started when we were all at Airbus in 2011 with the Cricri, which was, you know, kind of acrobatic airplane. It was a one seat, and that was 20 kilowatt at the time. Then, still in Airbus, we made this historical flight in 2015 with EFAN, who was a two-seater, and it was 60 kilowatt aircraft. And finally, we have been flying, and we will show you at the end, you know, in the movie, we have been flying our Voltaero Casio, equivalent the powertrain of a 10 seats, you know, to 600 horsepower. So between 2011 and 2020 now, we have multiplied the power by 30 even, excuse me, 30. Our goals is built on 3 priorities. Number 1, promote regional transportation, okay? It's an innovative way, sustainable and competitive, you know, solution for cleaner and more efficient ways to bring, you know, communities together and business together. And you know, when you think about COVID, you know, COVID has changed dramatically the way, you know, we're maybe thinking to fly. So, second priority is develop an e-Aviation ecosystem. As I said, we want to remove, I would say, aviation from the environmental equation. And this is very important, and we want to do it also based on the e-flexible and on-demand flight network, utilizing artificial intelligence basically, that can be enabled through smartphones, and teaming with also a French partner for airport infrastructure. French, or can be any part in the world. Today we are starting with France, but we want to be able to have the airspace support services and customers interface through that. So that's very much something that we're looking forward to. And finally, ensure Europe's position in e-Aviation. In Europe, we want to be part of, you know, the development. And this plane is made in Europe, but I should say we're very open to make it everywhere in the world through licensing. We're looking at, you know, expanding. So it's going to be made in France to start with, but rapidly we'd like to make it, you know, all around the world through licensing agreements. The key performance characteristics is to be safe, affordable, quiet, and with low emissions. It enters into the category that we call CS23. It's got 3.5 hours of autonomy. The range can go up to 800 miles in heavy hybrid. Takeoff and landing distance much less than 1,800 feet. 3 power levels, I said that before, 330 kilowatts for the 4 seats, 480 for the 6 seats, 600 kilowatts for the 10 seats. 200 knots of cruise speed, so 360 kilometers per hour. That's what we are looking at for a cruise speed, and 20% lower emission than competition in full hybrid mode. That means when you use your airplane in full hybrid. When you're using it in pure electric for short distances, obviously you got 100% of low emissions. So a revolutionary airplane and ecosystem comes together. This is the agreement, the partnership we have with Qingying, a US company, to develop a clean and on-demand regional flight services with the Casio aircrafts. Qingying has a flexible on-demand network that uses artificial intelligence, enabled through smartphone applications. And I would picture them as the Uber of the air. Casio aircraft will be integrated with Qingying short-haul infrastructure. And our artificial intelligence will balance passenger demand with air transport availability. Okay? Qingying software platform will interface directly with Casio intelligent cockpit, and this will show it in the future how we're going to do this. So when you got this, I would say software, that is embedded into your airplane and that can, drive customers and pick them up and optimize, like I said, and Uberization basically of the air, you need another dimension, which is the ecosystem that helps us, to pull all this together and get the infrastructure in the airports to be able to achieve that. Voltaero and EDIS is a French company and manages 20 airports in France, have the goal of developing sustainable and regional air transportation with our Casio aircraft. And we will focus on developing an ecosystem for short, medium, all air services. Voltaero will supply the Casio aircraft, while EDIS will provide the resources such as airport infrastructure, airspace support services, and customer interface. The joint vision includes encouraging the creation of associated distribution centers, training schools, and maintenance, repair, and overall facilities. This is the third very important step into our journey. So we, in the next slide, you'll see that we have received a seal of excellence from the European community. It's funded by the Europe's Green Deal Strategy and Recovery Plan. To support the development of Casio aircraft family, we were chosen by the European community for an initial 2.1 million grant, euros obviously, and also designated for blending financing at a higher value that includes an equity portion up to 11 million. So we're very proud of that. The jury has said that Voltaero was among the very top rated company, and we were among 2,077 candidates, and for this blended financing, I think only 25, all kind of industry included, were selected. So we're very happy, and the jury said at this stage it's a real innovation to the cycle of the sector and has the potential to impact the market. And there was also the recognition that the team is extremely knowledgeable and experienced in the establishing in the aviation industry. So this was very good for us. And now I would like to show you our hybrid electric powertrain platform. As I said, it was based on an existing airplane that we completely transformed, and the powertrain you see here is the equivalent of 10 seats. We had our inaugural flights in front of many people. It was on 27th of October, and I would like to share that with all of you. And we have been through this testing, all flights for going from 4 seats to 6 seats to 10 seats. So now we can move to the next step, which is our production aircraft. So I hope you will enjoy the movie, and I want to say thank you for this to all of you for having me in your forum.
So perhaps now, if yeah, so if everybody of this session comes back up to the screen, Arthur, you please as well. You can answer questions, and like I say, we will play the video afterwards. I'm sure we get it done. Like we played the videos yesterday. That's the first video which makes us a problem. I don't know why. So who else? I would have Fabio and Arthur, please, if you could come up to the stage, and then I start asking the questions I have.
Yes, Willie, I cannot start my video.
You cannot start. Okay, it should come in a second, and the same with Arthur.
Yes. Okay.
So now we're just lacking Arthur. Anyway, he just did send me a chat message.
It's okay. It's okay right now.
Okay, it's okay. Great. Then, but I don't have a video from you. Is this?
Yes, but I can't start my video too. I think you have to allow.
Okay, so you can start. Arthur Grunwald can start the video. So first question I have would be. To Qingying, are there any other projects you can share with us where Rolls-Royce is involved at this point in the commuter sector, or are the ones you mentioned are the ones which are public?
Yes, I think one project actually Fabio already mentioned. That's a Tecnam P-Volt based on P2012 traveler. And there is also another project which will be, I think, announced on the 12th. That means in 3 days from now by the funding body. It will be a UK funded project in the frame of Future Flight Challenge. But I think I will leave that to the funding body to for the first announcement.
Okay, I have a question to Peter. Because you, I've seen up to now when I saw images from the eSAT project, it was always the box wing design. Now on your videos, the design looks slightly different. Is this a new design? Because I heard some rumors, or what is behind this?
Very good looking at our pictures. First of all, we do have two companies, just as always in our aircraft business. So we have an airframe company and we do have a powertrain company. And I'm speaking today for the powertrain company. This is why we wanted to depict a general fixed wing type of aircraft into which all of our powertrains can be incorporated. However, it's true, if we look at the box wing, it has benefits, but it has also limitations. And the closer we have come to the real product development and certification aspects, the more we found that probably the benefits do not outweigh the drawbacks and the difficulties. So maybe sometime in the future we will show a different airplane that has a classical fixed wing, not a box wing anymore.
Okay.
But we have not done so officially yet.
Okay, and but the core of your development is more the aircraft or more the propulsion system? Where do you think is your focus?
Our focus is clearly the powertrain. We claim to be silent, and silence is clearly an aspect of the powertrain. And it's not the electrical energy conversion, but it's the propeller, the propulsion system that is loud, as we all know. So we have developed this significantly further, and we have also tackled the certification aspects and everything else. And so this is why we first focus now on where we have put more weight on the powertrain, and maybe 2 years behind in time, we're developing the aircraft. And we have two separate companies.
So yes, understood. Question, now the video is some problem still with the video of Arthur, but that's days of Zoom. Sometimes you have problems, sometimes it runs fine, but he hears us, which is the most important thing for questions. So because we all have seen your Casio 1, which is the modified Cessna. The next aircraft, when do you think the next aircraft, what is the timeline for your next aircraft, the larger one?
So I think what you just checked in the movie, it's, you know, what we call Casio 1 in our project. It was a proof of concept, a demonstrator, just an experimental aircraft in order to test our concept of hybrid modular system. And now we switch into our phase 2 in order to be able to produce and commercialize and enter into the market in 2023. The objective is to address the first aircraft will be a 4-seats aircraft addressing the CS23 certification, and we want to certify it in 2023.
Okay, so this is a challenging timeline. Same question to Fabio. What is the timeline you have for the P-Volt? Because I know for the P2012 Traveler, you had a lot of orders of Cape Air in United States, and the aircraft is flying and was gone to certification fairly quick. So what about the P-Volt? When do you think you have it in the air, and when do you think you will have it certified and flying with passengers?
Willie, first answer is regarding Cape Air, which is not the sole customer of P2012.
No,
we have
I know.
Other customers. And the second answer to your question is related to the certification. Yes, the P2012 was having a really aggressive certification timeline. It was a standard configuration, so a well-known aircraft architecture, and we started the certification process on 2015, end of 2015, and completed on end of 2018. So we know that the P-Volt will be not the same, not the entire part of requirement is ready. It is not sufficient to make an electric or hybrid aircraft to have something that is useful for the market. So now our goal is to arrive to a phase 1 of first flight of 2015. Phase 2, first flight will be on 2028. And certification we expect before 2030. Okay. We see this realistic timeline, also considering that we start with a really good part of job partially made with the P2012.
Very interesting. To Arthur, I have a question. What then would be the timeline, you know, of having an aircraft finally in service? Because like having the certification, yeah, but when do you think electric commuters will really transport passengers on a regular basis? And do you already have pre-contracts, for example, with transporting passenger companies saying, okay, yeah, when you have this aircraft ready at this time, then we would fly electric? And that's the same question I would also ask again to Fabio and to Peter.
So for Voltaero, yes, we have now some letter of interests of private owners and company who are ready to integrate our solution into their crew. So they are ready actually to support us, and are ready to sell our product when it will be ready. So the first version, the 4 seats, will be, the objective is to certify it in 2023 in order to enter into the service at the end of this year, 2023. So depending on our development phase, on our qualification test phase, this is the objective. So to be ready to enter into the market at the end of 2023 with some commercial companies ready to integrate this solution.
Can you disclose in which areas of the world they would fly?
In Europe and in the US at the beginning. At the beginning, it will be in Europe, of course, and then we will go to the US with the licensing agreement.
Okay, Fabio. The question from my side would be there: when do you think, or no, where are you doing the certification? Because the large market for the aircraft certainly is United States, but what about FAA? You're working with EASA now, as with all your plane. Normally you do EASA first. But you also have China on your schedule, because with some of the aircraft already produced in China, flying in China. So where is the heavy weight of where do you see the largest markets? And are you also working with other certification association already, authorities already? Or are you at this point mainly saying we do EASA first and then we look at the rest?
Well, the new requirement, new part 23, it is the good part is that the means of compliance are almost accepted by all authorities. So in the future should be, I hope, that will be more easier and at least faster to validate an aircraft. We have validated the aircraft P2012 in 8 months after the certification under EASA, and all other validation are quite fast. I'm sure this will happen also to the P-Volt. And yes, sorry, what was the other question? Concerning the authorities?
In which area you think you will, you said, but this you answered already. Okay, so
yeah, no, it's, I would like to add on this, because this was an interesting question.
Okay, yeah.
You know that this kind of aircraft, at least at the beginning, will cost not as a standard aircraft, will cost more. I don't know how much more. I don't know what is the final target price. We still don't know. We are working also with the Qingying and the Rolls-Royce, but they will cost more. So the first market to accept really this aircraft will be the market whose government will facilitate the introduction of this kind of aircraft. It's like the cars in the past, or something on the similar strategy. It's not just B2B case, but we'll have to involve communities, we'll have to involve governments, we'll have to involve requirements and so on.
This is very interesting. So I think I can pass along this pass as well to Qingying and Peter, because like I know you have made at Rolls-Royce a study. You're unmuted, Qingying, so perhaps you could unmute Qingying, and Peter should be unmuted. When do you, you have done a study on where the market could be first for small commuter aircraft, and can you share some of the data with this, some more of the data with this, like just a guess also, where do you think we can first time get into an e-commuter and fly from A to B?
Okay, I hope you hear me now.
Yeah.
Okay.
Yes.
So everybody knows the energy density of the battery is a limiting factor. So we put our focus to analyze which area of the world that the application of commuter aircraft will be more feasible due to this limitation. And we came to the conclusion, for example, in Scotland, there is many island hopping missions already in commercial aviation. And the second area is Norway, with its geographic characteristics, a lot of fjords. So other transport means like cars or train and CS-25 airplanes are not that populated. So I think both countries, especially for Europe, will be the first one for the commuter aircraft in service, which has already been partially confirmed by the local airlines.
Okay, and Peter, I think you probably also have, you started a project, like made a research when and where you could fly such an aircraft first?
We target to have in 25 a type certificate of the aircraft, and maybe a little bit earlier of the powertrain. And we're targeting indeed crowded areas, because silence is our unique selling point. So not flying into the cities, but flying close to the cities and or from one small airport to the other, where silence is important. So maybe somewhere in the outskirts in Australia, silence is not important. So we are targeting indeed like European, American, or Chinese, or whatsoever areas where neighborhood silence is very important. And also high safety requirements, certification requirements, because all of our electrical, mechanical, and thrust technologies are designed to be as safe as like a CS-25 type of aircraft. That's what we are targeting for.
Okay, thank you for now. And how can you get eFlight Journal? Just scan the QR code on this page, or just type in your browser www.eflightjournal.com. Then you receive the page with the latest online news on electric flying, eVTOLs, and everything which is connected with electric mobility in the air. Or you can click the link on the top, and then you go to the latest PDF version, which you either can read in the Yumpu reader directly on your screen, like a conventional magazine, or you can go and download the magazine as PDF file so that you can read it offline wherever you want. Thanks for watching, and goodbye.